Hi everyone, my name is Rachel Q. I'm the Vice President of Academic Affairs of the Computer Science Student Association here at UOttawa. Today we'll be doing a midterm review for ITI 1120, aka Introduction to Computing 1, one of my favorite courses. This midterm, unless it's changed recently, is all multiple choice, so it's very similar to the quiz that you had previously. So if you didn't do well on the quiz, here's your chance to catch up. Very theory heavy, and you really have to know exactly what Python is doing. So I'll show you a couple tricks that I use during the exam. We'll do some practice questions. If you have any questions after that for me, feel free to join our Discord server. We have a channel for ITI 1120. Send a text there and we'll get back to you as soon as possible. If you want some more one-on-one help after the midterm before your final, feel free to drop in during my office hours. They're posted on CSSA's Instagram. That's where you can find the most up-to-date information for that. And without further ado, I think we can just get started on the midterm review. If you really do not have time to review anything at all, this is a cram session, you can just skip to functions and the memory portions of these videos. They're timestamped for you, and those show up the most frequently on the midterm. So if you have no time, skip to that. But otherwise, let's get started with mathematical operations. So you should already be familiar with the two types of numbers in Python. We have integers, which are whole numbers, including the negatives and the zeros. And then we have floats, which are our decimal numbers. So anything with a decimal point is automatically a float. We can also convert between these two. So we have the int function to convert something from whatever it is to an integer if that's possible. There are some things we can't convert, like a list, but let's say I give you a string or a float, which we'll be covering in just a second, and we can return that as an integer. We'll return that as an integer and we'll always round down. That's the important part here. Okay, so let's say I have a float, which is 4.7. We know it's a float because it's a decimal number. So we have 4.7, right? We're going to round that down. So we're going to return 4, which we know is an integer. Okay? Similarly, we have a type conversion function for a float. So if I give it an integer, for example, it'll return that as a floating point number. Okay, so let's say we do float of 4. We're going to get 4.0. Okay, so we're just going to turn that into a floating point number. The important part here is that an arithmetic expression involving a float will always return a float. We'll see an example on this in the next slide. And then the division operation will also always return a float, just because division can result in a decimal number, so we want to preserve that. Otherwise, if both of the numbers that we're dealing with are an integer, we're just going to return an integer. Okay, let's see an example. So these arithmetic expressions and the operation should be familiar to you from math class. We have variables the same way. So for example, let's do x equals 9 or negative 9, and then y equals to 4. Okay? We have positive, negative signs, just like we do in math. So in this case, I have a negative 9. That's okay to do. We have the sum, which is x plus y. So negative 9 plus 4, that's going to return negative 5, okay? We have the difference, so negative 9 minus 4 is going to return negative 13. We have the product, so negative 9 times 4 is going to be negative 36. Okay? Familiar enough? Cool. Then we have the exponent, so x to the power of y. If we write this in our math notation, it would be x to the power of y. Okay, that's what's happening right now. So what's negative 9 to the power of, what's negative 9 to the power of 4? That's 6,561, if I'm correct. Okay? Now, the exponent operator is a little bit different because it will read right to left instead of left to right like everything else. Okay, so let's give you an example of that. Let's take 2 to the power of 2 to the power of 0. You might have heard what's happening based on just how I described that, but we're going to do 2 to the power of 0 first. So if we write this out, it's going to be 2 to the power of 2 to the power of 0. Does that make sense? So we're going to do an exponent this exponent first. So we're going to do 2 to the power of 0 first, and anything to the power of 0 is 1. So we're going to get 2 to the power of 1, which we know is 2. Okay? So just something to keep in mind there. I don't know if it'll show up, but just in case, that's important to know. Now we have division. This will always return a float. Okay? So even though both of our numbers are integers, if we do -9 divided by 4, we're going to get -2.25. And maybe now you can see why it's important that we get a float, because we can get decimal numbers from division. Okay? Now, this is the same even if we were to get a whole number by dividing. So let's say we did 10 divided by 2. Okay? We know that's 5, right? But it is still going to return a float. So it's going to return 5.0 actually. Okay? Just something to keep in mind there. That's the only thing that will always be a float. If both your numbers are integers, in every other situation, it'll be an integer. And then as soon as something's a float, everything's going to be a float. Okay? We'll see an example of that in just a second. Now we have integer division. So this will divide and then round down to the nearest integer. Just like our integer type conversion function, we're going to round down. Okay? So let's do -9, integer division 4. Now we know that a regular division is -2.25. So all we have to do is round that down. How do we round that down? That might seem like a silly question, but let me show you a number line, okay? If you're thinking it's -2, that is wrong. Okay. Let's say I have my 0 here. Just for comparison, let's do 9 divided by 4, or divided by 4, okay, which is +2.25. Okay, so here's our 1, here's our 2, here's our -1, here's our -2. So normally we would have our 2.25 here, and then when we round down, we're going to round to 2. Okay, so we're going to go left on the number line. That's the important part here, okay? Now we have our -9 divided by 4, we're at -2.25. So we're going to go left on the number line. We're rounding down. So this is actually going to be -3. Okay? Because this is our -3. We're going left on the number line. That's the important thing. Here, left, left. So for positive numbers, for the +9 divided by 4, we're going to have 2 as our integer division. But for -9 integer division 4, we're going to get -3. Okay, I hope with the number line that makes little sense. We're moving left on the number line. Okay, we're becoming more negative. Another way to think of it is if we're rounding down, our number is getting smaller. So -3 is smaller than -2. If we rounded -2.25 to -2, that's a bigger number. We're rounding up. So we're rounding down. We're going other way, okay? Just something to keep in mind because I think that will come up. And you can draw on your paper as much as you want. You can draw a number line if that helps you, okay? Whatever gets you the grade. Now let's do the remainder of integer division, also known as our modulus operator. This one's a little tricky, and they always ask about this from my experience. So in this case, we're doing -9 mod 4. What does that mean exactly? So here's the equation, right? So it's x minus the integer division of x and y times y. So we can use this equation, but you also can kind of reason through it if you don't want to memorize this. I'll show you both in a second. So let's do -9 minus the integer division of x and y. We already established that's -3, okay? Times y. Perfect. That's just 4, okay? So this is -9 minus -12, which is the same as -9 plus 12. So that's just going to be +3. Now, if we don't want to think of it like this, if we want another way of thinking of the mod operator, because it can be a little tricky, right? If you don't want to memorize this, let's take some easier numbers. Let's do 13 mod 4. Okay? This is how I think of mod. the modulus operator, I'm going to think of how many times I can get 4 into 12. What's the biggest number I can get by putting 4 into 12? So we can do 4, we can do 8, and we can do 12. If we go again, we're going to get 16, and that's too big, okay? So we're going to stop at 12. Sound good? So we just subtract these two numbers now. 13 minus 12 is 1. So therefore, the 13 mod 4 is equal to 1. If you don't believe me, let's do it with the equation. 13 minus 13 integer division by 4 times 4. So what is 13 divided by 4? It's going to be 3 point something, right? So if we round that down, we're just going to get 3. So this is 13 minus 3 times 4, which is 12. Or what? Which is 1. It's 13 minus 12. Okay? So that's just another way of thinking of it, okay? How many times can I put 4 into 13 and then just subtract that number from 13? That's the remainder. Now, all of these except for division returned an integer because both of my x and y are integers. Now, as soon as one of those is a float, or if both of those are a float, but at least one of those is a float, everything is becoming a float, okay? So let's do x equals negative 9.0. Now that's a float. So everything here becoming a float. So our sum, going to be a float. Difference, float. Product, float. Okay, exponent, float. Our division's already a float. Integer division is going to be a float. Remainder of integer division, oh, that was 3. And that's going to be a float. Okay? So as soon as something's a float, everything's a float. Otherwise, everything's an integer except for division. Just like in math, we're going to follow an equation in the order of PEDMAS. So parentheses first, then we'll do an exponent, we'll do division, multiplication, and addition, subtraction. If that's not applicable, we just read it left to right. So if I had x plus y plus z, I do x plus y, and then I do whatever that is, plus z, okay? And then after that, we'll do our Boolean expressions. So what is a Boolean expression, you ask? Well, it's something that returns a true or a false, a Bool value, a Boolean value, okay? So these are your comparison operators, which are right here, right here, and your logical operators. So we do comparisons first, and then we do logical operations. So let's take our x and our y back, the same one. So x equal, we'll do, it doesn't matter if they're floats or integers now because we're returning a Boolean value, and we'll do 4, okay? So the comparison operators you should be familiar with from math. So is negative 9 less than 4? That's going to return true, right? Because negative 9 is less than 4. Is negative 9 less than or equal to 4? That's also true. Is negative 9 greater than 4? That one's false. Is negative 9 greater than or equal to 4? That one is false. Now, here's the equal operator, right? So in math, we only have the one equal sign, right? If I were to do x equals to y, and I want to say if that's true or false, in math I can do that. But in Python, we leave, or in coding in general, we leave this single equal sign as an assignment operator. So in this case, you can see this up here. Up here, these, I was assigning values to my x and y. So by doing x equal to negative 9, I'm setting the value of x to negative 9. So I'm putting negative 9 in my value, in my variable x, okay? Same goes here. I'm putting 4 in the variable y. Okay, so what happens when I do x equal to y? I'm not actually asking if x is equal to y. I'm putting the value of y into x. And we know that's 4, so I'm actually doing x equal to 4 right now, which is not what we want. So instead we use this equal operation here with the double equal sign. So this is going to ask, is negative 9 equal to 4? Are they the same number? Which we know is false. Sound good? Follow me so far? Cool. Similarly, we have not equal to. So is -9 not equal to 4? That's true. Now we have our logical operators. So this goes in order. So not goes before and, goes before or. Now the not operator is going to switch the value of our Boolean, okay? It'll make a little more sense if I show you this. So what is not true? Well, that's just false, right? And what is not false? Well, that's true. So just gonna switch it. So false goes to true, true goes to false. Now, and is going to be true if x and y are both true. So basically when we have true and true is going to go to true. Everything else is going to go to false. So if I have true and false, it's false. If I have false and true, it's false. And if I have false and false, it's obviously false. Now the or, I only needed one of them to be true. They can also both be true. But so if I have true and true, that's going to be true. If I have true and false, oh sorry, true or true, true or false, that's also going to be true. False or true, so the other way around, is also true. As long as one of them is true, the whole thing is true. And then, by consequence, both of them are false, then we get false. Okay? Make sense? I hope that was review, because it gets harder from here. Let's do an example. Uh-oh. They will totally do this to you on your midterm. I apologize in advance. They're not going to give you parentheses. They're just going to give you a mean equation, and they're going to ask you to solve it. Let's start off with the one with just arithmetic operations. Okay, so this just follows PEDMAS. I find it easier to write this out as using standard math notation. I think it's a little easier. But you don't have to. You can also just write parentheses around everything or just solve it as it is. Okay, so let's start by looking. Do we have any parentheses? No, because they're mean. They're not going to tell us what to do first. That's up to us, okay? Do we have an exponent? We do. Here's our exponent operator. We're doing 2 to the power of 2 right there. So we know that this right here is going to be 2 to the power of 2. Okay? Do we have division? Yes, we have 8 integer division by 2 to the power of 2. So let's add that there. And I'm just going to add brackets around that so that we know that we're valuing that first. Okay? Do we have multiplication? We do. We have 3 times all of this, right? So let's put 3 times that. And then we have our addition and our subtraction. So 5 plus 3 and 3 times everything, and then subtract all of that. Subtract 7 from all of that. Okay, so I hope that makes it a little easier to read now. So we're going to evaluate our parentheses first. So 5 plus 3, we're going to evaluate inside here and subtract 7. Okay, so let's do 8. We're going to do the exponent first. So what's 2 to the power of 2? That's just 4, right? Now what's 8 integer division by 4? That's just 2. Okay. We have 5 plus 6 minus 7, which is just going to come out to 4. Okay? Wasn't too bad? I hope so. Okay? Now we have that combined with Boolean expressions. Now remember, we're going to do not, and then or in that order, okay? And then we're going to do comparison operators before all that. And we're going to do arithmetic expressions before that. I hope you remember that from the last slides. So let's put some brackets around this. It's going to look really rough, but it's going to work. let's start with arithmetic. I have a 3 times a 2 right here. Okay, and I have an 8 mod 3. That's all I have for arithmetic right now. Then we'll do comparison operators. So I have a 5 less than or equal to 10. I have the 3 times 2 greater than 6. And then I have the 8 mod 3 not equal to 2. So now all I have left is an and, an or, and a not. Well, we're going to evaluate that not first, right? Okay. So now I have an and or. We're going to evaluate the and first. So basically we have this here or this here. Okay? Maybe it'll be a little easier when we actually do it. So we're going to evaluate our inner parentheses first. That was our arithmetic expressions, right? So here and here. We know that 3 times 2 is 6, so we're going to get 6 greater than 6 as our comparison operator. Or here's a chance for review. What's 8 mod 3? How many times does 3 go into 8? Well, I know that 3 times 2 is 6, right? I can't go any bigger than that because we'll get 9 and that doesn't fit in 8. And so we just subtract 8 minus 6, that's 2. So 8 mod 3 is 2. Okay. Now let's just do the comparison operators. So remember, these are Boolean expressions, so they're just going to give me a true or a false. So is 5 less than or equal to 10? That's true. And is 6 greater than 6? Well, it's not a greater than or equal to, it's just a greater than, and 6 is not greater than 6. So we're going to get a false here. And then we'll get an or, and we'll do not. Is 2 not equal to 2? That's false, because 2 is equal to 2, so false. Now remember, our not is going to flip our Boolean, so false is going to go to true. So we're going to get true here, for sure. Okay? And then remember, and is only true if both x and y are true. So in this case, we have a true and a false. Well, both of them aren't true, so it's going to be false. And now we have a false or a true. With an or operator, if x or y are true, then it's true. Okay? So in this case, we actually do get a true. Yay! Right? I was just doing some practice problems about these if you don't get it yet. But otherwise, let's move on to strings. Now, the important part about a string, we'll do a whole section on this later in memory, is that it's mutable. We cannot change that string. Okay? It's an immutable sequence of characters surrounded by single, double, or triple quotation marks for a multi-line string. And we can display that in our console with the print function, okay? Now you'll see this function a lot, just end equals, or this parameter end equals to a string. Very frequently, it's usually end equal to just a space. Because when we print, it'll print whatever string you give it, and then it'll print a new line. So let's say we're printing 1, 2, 3, 4, right? So it's going to print 1, it's going to print a new line, 2, new line, 3, new line, 4. Okay, if we don't want that, let's say we set it to end equal to just a space, right? It's going to print 1 space, 2 space, 3 space, 4 space. Now that can be any string. So let's say we put a comma and a space there. Then it'll be 1, comma space 2, comma space 3, comma space 4. Okay, this would actually also have a comma space. That was not too important to know really, like in terms of usage. It's more that you'll see that a lot during the midterm, just because they don't want to waste paper by having a bunch of empty lines or almost empty lines. So they'll just have spaces between your print statements. Now we can concatenate strings, so we can combine them together with the plus operator. just like the same plus that we saw last time. Now there's a problem with that one. We'll get to that one in a second. Or we can print multiple arguments with a comma. So we can do print string 1, string 2. You can also print like an integer. And each of these divided by the comma is an argument. So this is 1, 2, 3 arguments. They will actually ask you about this, but I'll show you the situation that they ask you it in. Okay, just keep that in mind. If we concatenate strings with the plus, it's still one argument because the arguments are divided by the commas. So if we don't have commas, we have one argument, but it just kind of smushes them together. We'll see that in a second. Whereas if we print as separate arguments, it'll automatically print a space in between there for us. Sound good? Now, since we have this plus operation, right, or plus operator, we have to convert integers and floats into strings. So we have to convert numbers into strings before we can concatenate them. So the type conversion function, just like the int and the float, is just string, str. Okay? Now, why is that? Let's take here, for example, right? We have print a string ITI, and we want to combine that with 1120 as a number. The issue here is I have this operation, this plus operation, right? This plus operator. I have that for both strings and integers. So I'm either concatenating these two, if we were to treat them both as strings, or I'm trying to add this, right? Like I'm trying to do 1120 plus 5, right? So I don't know what's happening here, and this actually won't work at all. This will just crash. Okay, so we have to convert a number into a string before we can concatenate it. So in this case, I have ITI plus the string of 1120, the string version of 1120. So that's going to be 1120. Okay, so we're going to put that right here. Okay, so this value is 1120. Okay, so remember when we concatenate things, we just kind of smush them together. I don't care if there's a space in it. It's just going to be ITI right next to 1120, no space. Okay, we just smush them together. Sound good? Okay, now we have ITI and a comma. So these are separate. These are separate arguments, right? Now we know 1120 is right here. So it's going to be ITI space 1120. Now, how many arguments is in this line, or in this print function? It's actually 2, because we have 1, 2, separated by the comma. Now here it's just the 1, because we're concatenating them. It's still taking one string in your print function, but here we're taking 2 separate strings. Okay, so 2 arguments. This is where they tend to like asking you how many arguments are in a function, because it does seem a little bit tricky distinguishing between concatenation and just having separate arguments, right? Now here we have ITI 1120 just straight as a string. We don't need to convert it. So that works as well. We're going to have ITI. Remember, if there's a comma, there's 2 arguments, it's going to automatically print a space for us. So we're going to get 1120. And this is 2 arguments as well. We can also manually add that space. So we could get ITI smushed with a space. So here's my space, and then 1120. Okay, now this, because we're just concatenating them. This is still considered one big string. So this is one argument. Okay, that one's important. Sounds good? Cool. Now let's take a second to talk about type conversion. So last slide we did this, right? Now let's see how that's actually working. Let me give you an analogy really quickly, okay? Let's say I have an x plus a y, right? We'll set it to negative 9, 4 again, right? What does this equal? That's negative 5, right? But does that affect x or y? Did my y change? Did my x change? No, we still know that x is negative 9 and y is 4. We have a brand new number here, right, that we can choose what to do with it. So let's say this is my z now. Okay? So now I can use this z all I want. I can do x plus y plus z. You know? But the key thing here is that it didn't change my x and it didn't change my y. It's a new number. We could also do this. Let's say x plus y. Okay? This is the same as x plus z. Okay? So we can use that all we want. We can use the z. We can throw it away if I never need this number again. Doesn't matter. Key thing, it's not changing my x, it's not changing my y. Now, how does this apply to type conversion functions? Let's take our course number. So 1120. I know that's an integer, right? So when we find the type of it, it's just going to tell us it's an integer. Cool. We know that one already. Now, if I do string course number, it's going to give me a string version of the integer. So it's going to give me a brand new thing. This is 1120, right? As a string. But that didn't actually affect my course number. So this is still going to be an integer. Does that make sense? Let's go through that again. So we have our course number, it's 1120. If we do string course number, we're going to get a string version of our course number, but it's not turning my course number into a string. So we can set string course number to this. And this will get us the 1120 as a string. And so we're just going to put it in here. Same as how we did z equals x plus y. Whatever this is, we'll just put it in there. But it's not changing my x, it's not changing my y. In this case, it's not changing my course number. My course number is still 1120 as an integer. I just have a brand new variable that I assigned 1120 as a string. Okay? So obviously, when I ask what's my course number, what's the type of my course number? Well, it's talking about this variable here, not this one. This one. Okay? So it's just going to tell me that's an integer, because it is still an integer. Okay? We can also use this again, so I can print that out here. So I can print 1120, same as how I could do x plus z, and that would be x plus y, right? I could print that course number out as a string. I could use it all I want. I can either use this one or I could use this one here. Main thing is, I didn't actually change my course number. Okay? I never touched this variable. I only made a new one. We'll see why that's important multiple times over the course of this review session. Now let's go further into strings. So we have a function here, len of s returns the number of characters in our string s. But let's say I have hello as a string. How many characters in this? So h is 1, e is 2, we have 3, 4, 5, and my exclamation mark is 6. So the length, the len of hello Okay, 6. We can index strings, but we can't change them because they're immutable. So let's see this in action just a second. Just remember that the first character is going to be 0 because we start counting at 0. I have a string here called my string, okay? It says, good luck on your midterm. How cute, okay? Now, the first character is going to be at index 0, right? So let's count these indices out. So what is at position 0? That's my G, my capital G. So if I index for position 0, I'm going to get the first character because we start counting at 0. So I'm just going to get G. Sound right? Cool. Now what's this here? It's the length of my string minus 1. Because we saw here length starts counting at 1. Because obviously if I have a string with just a letter, how many characters are in that string? Obviously just 1, right? It wouldn't make sense if this was 0. Even though this is index 0, we have 1 character there. Okay? So I just wrote out the indices to make it a little bit easier. The length of this string is 26. I have 26 characters in here. Remember, spaces count as characters. Okay? So what's 26 minus 1? That's 25. So this is the same as my string, 25. And what's at index 25? That's here. That's my exclamation mark. Right? Sound good? That's what we got here. Cool. All right. We can also go backwards. So key thing here is the last is -1 because we don't have a -0. So these indices are equivalent here. So the last one is -1, then we have -2, -3, -4, -5, -6, -7, -8, right? What is the character at index -8? That's the same as the character at index 18, which is this here, this M. Now, I'm trying to change that to a capital M. But we learned previously that we can't change them. They're immutable, okay? So this won't work. This will actually crash. I can't change my string. The only way for me to quote unquote change it is to entirely replace it with a new string with the change that I wanted. So in this case, I want to capitalize M. So it's a brand new string. Good luck on your midterm with a capital M. Okay, that's the only way that I can quote unquote change it. I'm not allowed to actually alter the string in any way, so I can't do like this, right? The only way is for me to completely replace the string. Brand new string, everything's the same except for the thing that I want to change. Brand new string. Important part here. Okay. Now we're on to string methods. These are pretty easy. The big thing here is that strings are immutable, so none of these are actually changing my string, okay? They're just giving me a copy with the thing that I want different. Does that make sense? Hopefully. Let's look at last slide, right? It's basically doing this. Since I want to capitalize my M here, I want the lowercase m to become an uppercase M. Instead of doing that, we're giving it a brand new string that has the changes I wanted applied, but it's a brand new string, okay? My original string did not get affected. Let's see how that applies here. So I have my string, my lovely string with my Computer Science Student Association, right? If we print the uppercase version of that, so we do s.upper, it's going to give us a string with everything uppercase. Cool. But that didn't actually affect my original string. So if I print my original string out again, I'm just going to get the normal one. Okay? Now, if I wanted it to be uppercase, I can reassign it. So I could do S equals S dot upper, right? Because that would put this into my S. So every single time I use S, I'm using this brand new string, right? But if I were to just run S dot upper, it's just going to give me a brand new string. I can choose to save that. I can choose to throw it out. Doesn't matter. But it's not affecting my original string S. Okay? S dot lower does the exact same thing. So if we did S equals S dot lower, right, and we print S, we're going to get Computer Science Student Association, just all lowercase. Alrighty. Then we have s.strip. It returns a copy of the string without leading and trailing space. So here I have my name. I have a bunch of empty space right before that. If I were to print my name without the empty space, it would just be Rachel Q. Notice that it's just the leading and the trailing space here. The space in between doesn't actually get affected. Remember though, this does not actually affect the string name, the original string. So if I were to print this out, I would have a bunch of empty space. I would have Rachel Q. I have a bunch of empty space again. Okay? Because it doesn't affect the string, it's just giving you a copy. And you can choose what you want to do with that copy. I can set name equals name.strip. If I want to only ever use this one again. But otherwise, if I don't have this, my name is just staying the same. It's still going to be this one here. This is a brand new string. Cool. We also have a searching method. So in returns true if my target string is in S. Okay? It has to be the exact same capitalization, order, all of that. So let's take my string. It's midterm prep. Is M in my string? So for each character, we're basically going to do is the target, so is M equal to whatever index I'm at. So let's say my string, let's say this is I, right? So in this case, it's the very first one. M equal the M, the one that we want, is in my string. It's the first character. How lovely is that? So this is going to be true. Okay. Now, is this capital T in my string? I have a lowercase t, but when I do this, that's actually false, because these are not the same character. So this is going to return false. Same with this here, MRP. I do have an M, I have an R, and I have a P. But I don't have MRP together like this in that exact order, in that exact capitalization, right? So this is going to be false as well. So we can also count the number of times a target string appears in our string. So in this case, I have a string Mississippi. I'm looking to count the number of I's, and this is basically what it's doing. Don't worry if you don't understand this, because we'll be looking at for loops and conditional loops in a second. But in layman's terms, it's going through each letter of our string, so Mississippi, and it's just checking if that's equal to our target. So for example, the first time around, it's going to go is M, or I guess it's I, equal to M. Not true, so we're not counting that. Then it's going to do is I equal to the second one, I. That's true, so we're going to up our count. So now we're going to do count equals count plus 1, okay? And we're basically just going to count that way. So we have count 1 here, this one no, count yes, no, count, no, count. So we have 4 I's in total. So that's the number of times our target string, which is an I, appeared, which is 4. So that's what's happening there, okay? So now we're going to do slicing strings. It's important to know how this works, especially because this right here, this index operation with start end step is, we'll see that very frequently. So the start is basically the index you're going to start at. End is the index you're going up to, but not including. End is exclusive. Okay, so we're going to, let's say this is 0 and 9. We're going to go 0, 1, 2, 3, 4, 5, 6, 7, 8, but not including 9. Okay? And then step is how big of a step we're taking each time. By default, this is 1. So we do 0, then we do 1, 2, 3, 4, so on, right? Let's say if we change this to 2, we're going to take a step of 2. So each time we're going to 1, 2. So we're going to print 2, 1, 2. We're going to print 4, 1, 2. We're going to print 6, 1, 2. We're going to print 8. Okay? We're just taking a bigger step each time. By default, that's 1. Okay? So let's take our original string, right? Now here we're going to concatenate the original string from 0 to 3, or index 0 to 3, and then we're going to add a little exclamation mark. Yay! Okay, that's exactly what it says too. What a coincidence. So we have our original string, yay Python. Just going to rewrite it out so I can write the indices in. So this is 0, 1, 2, space counts, 3, 4, 5, 6, 7, 8, 9. Okay, so from 0 to 3, not including 3, that's 0, 1, 2. Right? So it's yay. Cool. And to that, we're just going to concatenate it with a plus, or a plus. We're going to concatenate with an exclamation mark. So we're going to get yay with an exclamation mark. How cute. Okay. Now let's make a substring. Okay. So once again, indexing, slicing, all the methods, they are not editing your string. Your string cannot change. You can only you can only replace it with a brand new string. If you want to set like original string, say this is original string, you can set this to it. Like we can give it a new string, but we cannot change that string. Okay? So here we have a substring, which is from the start to the very end, because there's nothing there, so we're going default. So from the first to the very last index, and we're going to take a step of -1 each time. What does that mean? So we're going to go backwards like this. So it's going to print it backwards. So we're going to do 9 first, so we're going to do n, and then 8, because we're stepping down by -1 each time, right? So now we're going to do the character index 8, so we're going to do O, and then H, and then T, and then Y, P, space, Y, A, Y. Okay, and that's our substring. Right? Notice how we had to save that. So we got yay Python backwards. Oh, I forgot my little... That should not have an exclamation mark. There we go. Just gonna fix this here. We're gonna go to -1. Okay, so we're gonna start at 2, index 2. Remember, we're going with our original string. When we did this, we made it into a substring. Our original string did not get affected, so our original string is not reversed right now. It's this string right here, i.e. Python. Okay, so we're going to start at index 2, that's a Y. We're going to take a step of -1 each time. We're going to go this way. -1, -1, this way. Okay, so we're going to go at index 2, which is Y. Index 1, which is A. And then index 0, which is capital Y. And then we aren't going to include the end, right? So we're not actually going to go to -1. Remember, -1 is the last number, so it's the end. But we don't include the end, okay? Up to, not including the end. Now let's do original string from the first index, which is A, right? We're going to take steps of 2 each time this time. So we're going to go 1, 2, that's 3. So that's just a space. Okay. 1, 2, that's at index 5, so that's a y. 1, 2, up until 7, that's an h. 1, 2, up until the very end of our string, that's an n. So important thing here is just that we're not changing the original string at all whenever we index these operations. Even if we're doing something like reversing it, it's not affecting our original string. And then end is not including the end. We're going up to, not including the end. Okay. Let's have some more fun. We're doing functions now. We love functions, just like in math where we have f at x equal to something, right? We get one output out of it. Same thing here, we have 0 to many inputs going to 1 output, which is 1 return value. And it's defined but not run with the def keyword. Okay, so in this case, we're defining a new function. It's called name a function, and it's taken 2 inputs, 2 parameters. And then pass, you might see, it just does nothing. It's just so that you can define something with nothing inside of it and not have an error. Cool? So that's how we define a function. Now here are our doc strings. So the documentation, it tells the user how to use it basically. So we have our type contract, which is the accepted input type, and then we give it the return type. So these are the types that we know in this course. So we have our string, an integer, a float, a list, a tuple, and a Boolean, and a none. So you can return none. That counts as your return. A tuple is just a grouping. So, for example, x, y. If we were to return a coordinate system, we can return x, y, and that's a tuple. Okay, you won't really see that in the exam, I don't think. Okay, and then preconditions for the function's result to be correct. For example, let's say we're doing the area of a circle. We want the radius to be bigger than 0, bigger than or equal to 0. Because it doesn't make sense to have a negative radius. The function could work, but we won't accept that parameter. Sounds good? Okay. And then sometimes you can just leave a description of what it does and an example of like a run output. Sometimes you'll see that, just so you know that it can be there. Now the important thing here is when we return or just print. So returned value can be saved, okay? But a printed value cannot. It just gets printed out and you cannot do anything with it further. We'll look way more at this, don't you worry. Cool? So let's do an example. Let's make a function that describes the area of a rectangle. So I know that the area of a rectangle is length times width. Right? So let's just turn that into some code. So let's define the area of a rectangle as a function. And I have 2 parameters. I have length and I have width. Now you won't be writing in your midterm. This is just to show you an example of a function, okay? Because sometimes you'll be asked to complete part of it. So let's put our doc strings in. So I'm saying that I want both my length and my width to be floats. Okay? And with that, I'm going to return a float for you. I'm going to calculate the area and return it as a float. So the precondition here is that length has to be greater than or equal to 0, and width has to be greater than or equal to 0. Because it doesn't make sense for me to have a negative area. You could solve it by, for example, using absolute value, but I'm just going to put in my precondition. Don't do that. My function's not going to work. Cool? And we're just going to let people know that it returns the area of a rectangle in units squared. Cool. That's my doc string. Okay. Now, very simple. What am I returning? I'm just giving you the area which is length times width. So I'm just going to return length times width. Cool? Cool. Now let's look at some usages, okay? So to call a function, for example, when I call area of rectangle with a random length and width, it becomes the focus frame, and whatever called it is just going to pause. So it's not going to keep running the code. It's going to wait for my area of rectangle function to run, and then it's going to continue on with whatever it was doing before. Okay? So variables created by a function are not going to exist in the global frame. So that's like your main running frame. Okay? That includes the input parameters. So if area of rectangle defined anything, here it's defining your length and your width parameter, right? It exists solely for that function. We're going to see why this is important in just a second. I can access all the variables from the global frame, but the global frame cannot access anything in my function. Okay? So it's not going to be able to access my length and width. We're always going to use the local variables inside my function, or the parameters here, before I go looking elsewhere. We're going to see this. I promise. Bear with me for a second. We're going to terminate immediately if we see a return statement or if it crashes. And then we can also call other functions within our function. Let's see this in action now. Okay, guys. Here are our examples. So I have an area of a rectangle here. Curiously, though, it doesn't have a return statement. That's okay. That's allowed. It just means I can't do anything with it after. We'll see that, okay? So let's finish the doc string up first. So we're not returning anything. We're also not taking in any inputs. So it's going from none, and we're returning a none type as well. Okay, it's just going to print out length times width. Now, let's go in order of how Python runs code. So it's going to run this here first. Okay, we're going to start up here. Let me change colors. We're going to run this first. We're just interested that there is a function called area of a rectangle. Other than that, I don't care about it. Okay? Until area of a rectangle is called, I don't care what's in it. So we're just going to skip. This is a comment, so we're not going to do that. We're going to go here. Okay? Okay. So we're going to set length equal to 5, width equal to 5. Okay? And then we're going to run area of rectangle. So we're going to go back here. Cool. Now I care what's in area of rectangle, okay? So you might think that this won't work because we're going to go here next. You might think this won't work because I'm going to look inside my function first. And I don't have a length or a width. But because of the order that Python runs, right, we've actually defined length and width here in our global variables. And my function can access global variables. So I know what length and width are. This is 10 times 5. Okay? Cool. So we're going to print out 10 times 5, which is 50. So this is going to print out 50, right? Now, what happens if I try to set that to a variable? Now, I'm not returning anything. So whenever we assign things, so we're going back here now. Whenever I assign things, I'm going to run the right-hand side. I'm going to run that, and then I'm going to assign that to a variable called area. So we're going to go back up here. Let me erase some. So we're going to go back up here. We're going to run this. So this here is getting run. So we're going to print 50 again. And we're going to assign something to area. What did we return? We returned nothing. So area is just nothing right now. Okay? And if I were to try to use area further, like let's say we did area equals area divided by 2, right? It would crash on us because area has nothing in it because we didn't return anything. We just printed it out. Okay? So we have it printed out twice because we called it twice, and each time it prints something, technically. But it didn't return anything. I can't use this value anymore. I just printed it out. It's gone into the console. It's just showing it off to you, but it's not giving you anything, okay? Sounds good? Cool. Let's look at our next function. So remember, we're going to start off here. Okay? I don't care what's in here, really, but just to finish our doc string, I see there's no return value again. So this is an untype. Okay. Other than that, don't look here. We don't know what's in there. I'll cover it up, actually. Okay. Cool? Cool. Now we're going to go here. Oh, no, that's a comment. We're going to go here. Okay? Now I care what's in my function. So we're going to go back up here. I know it's a little, like, circular, but now I care what's in it. So we're going to remove that tape. Look at it. Okay. So I know we're going to set length. We're going to set width. So this is our 4 and our 5. And then we're going to print this out. We're going to print length plus our little multiplication sign, or an x plus width. Okay? So we're going to print 10x5. Okay? Now that that's done, I'm going to come here. And what happens when I exit that function? I don't care about it anymore. So we're going to cover that up. Now you might see a problem. I'm trying to print length. What is length? I've never seen a length before in my life. It's in the function. I don't know what's in the function anymore. I only care about that function when I'm actively using it. Now I don't know what's in the function. So this is going to crash because I don't know what that length is. I've never seen that in my life. We're going to pretend that Python has no object permanence. It doesn't know. As soon as length is out of its sight, it doesn't know what it is anymore. It's gone. Okay, so we don't know what length is. It's going to crash. Cool? Cool. Hope that made sense. Let's go do some more examples. Okay, now we have an increment function. Cool? Cool. We have one that prints, or one that doesn't return and one that does. Okay, so here, no return statement. So this is going to return none. Okay? Versus this one, we have a return statement. Oh, we love that. We're going to return an integer. Okay? Let's start off on this side here. So we're going to start running from the first line. We're just going to say, oh, yep, there's an increment function, totally. We don't care about anything that's in it. I'm just going to cover that up for now. We just know there's such thing as a function called increment that takes in one parameter. Cool? Then we're going to go down. We're going to go x equals to 5. Okay, so we're going to assign 5 to x. So, okay. Then we're going to print out x. So we're going to print out 5. Cool? Now we're going to run increment. Cool. Now I'm going back up here. Okay, now I care what's in here. So I'm going to set, we gave it x. So I'm going to set num equal to x first. Okay, so now num is equal to 5. Cool. Now I'm going to increment that by 1. So now num equals num plus 1. So num equal to 6. Cool? Cool. So from that, we have num equal to 6. Now we're going to go back. This was 6. This is 7. We're going to cover this up. We don't know what happens to the function as soon as we leave it, right? And I'm going to print out x. What is x? It's still 5. Interesting, huh? It's because everything in the function that we did here, we did to the variable num. Okay, we didn't actually do anything to x. So we changed num, and then as soon as we exited the function, it's gone now. So we basically just did nothing, and we're just going to print out the exact same thing, because x did not change. Okay? Let's see something again. This is going to do the same thing for now, but we can change it a little bit to make it do something different. Cool? Now, we're going to run from here again. Okay, we know we have a function the increment called increment, and it takes a parameter num. Cool. Then we're going to go to our normal function or to our main. We're going to see x equal to 5. Okay, sounds good. We're going to print out x again. So that's 5. We're going to print out 5. Cool. Now we're going to run increment x. Okay, so we're going to go back up here. We're going to open that function up. We're going to say hello. And we're going to set num equal to x again. Okay, so we know that is equal to 5. Now we're going to increment that. So num equals num plus 1. So num is now 6, right? And we're going to return that. Okay? So now I have num equal to 6 somewhere. Okay? Cool. Now we're going to cover that function back up. Okay? And then we're going to come back over what number we want. This was 6, this was 7. We're going to come back down here to 8. Okay, and we're going to print x. That's still 5. So that's the same exact logic as this first function here. So I hope that makes sense. Now let's see how we can change it. Okay? Now, if I were to do this, do you see why it's important that we return now? Okay, let's show what happens. So we're gonna go here. Remember, we don't know what's in here. We're gonna go x equal to 5. We're gonna print out 5. Then we're gonna come here. We're gonna run increment x first. Okay, now we're going back up here. Okay, now let's look at our function. So we're gonna run num equals num plus 1. We know that num is x, that's 5. Num equals num plus 1, so num equals 6. And I'm going to return num. Okay? Now this has a return value. So this right here, you can think of this as num. Right? And you can think of num as 6. So now we have 6 being assigned to x. Okay? That's what's happening here. So even though this closes, right, and we don't know what num is anymore, because we returned it when we come back, we can assign that to x. So now x equal to 6. Okay? I forgot what count we were on. 7. Nope, that's 7. We're on 8. Okay? Now when we print x, we're going to print 6, just like we intended, okay? So that's the difference here. When we return, if we are collecting that return, we can update it, okay? But otherwise, this here is its own function. As soon as we close that function out, we don't know what's in it anymore, okay? I'm going to show you the exact same thing. I promise it's the exact same thing. It doesn't look like the exact same thing, and this is where they get you. Okay? This is why I like to just rename everything, because it makes it easier. Because when you see this, right, when you see x equal to x plus 1, you're going to assume that it's applying to this one. Okay? But this is the exact same thing that we've already done. Let's replace this with number. Let's replace this with number. Let's replace this with number. Okay? Now you can see what's happening. Okay? So we run this, we do x equal to 5, we're going to print out 5. When we increment x, it's going to set num equal to x. Okay? So number is getting incremented. So number is going to become 6. Okay? But as soon as this closes, especially because we didn't return it, we didn't capture what we returned, we don't know any of that anymore. So we're just, when we print out x again, it's going to be the same x, right? Okay, this is 5, 6, we're going to come back here, 7, and we're going to print out 5 again. Okay? Now let's rename this again. So this is num, this is num, this is num. Feel free to rename things. That's how I solved all my midterms for Python. I just renamed whatever was in the function, because they will set it to the exact same thing to confuse you. Cool? So we're going to go here, we're going to go here. We're going to print out x, which is 5. We're going to run this. So this is covered right now. We're going to run increment x. So we're going to set num equal to x, which is equal to 5. Okay? So we're here. We're going to set num equals to num plus 1. So that's 5 plus 1, which is 6. Okay? And then we'll return num, and we're going to capture that into x. So this is now 6. Right? So we're going to cover that back up. And then whenever we come back down here for step 7, no, I did this last time too. For step 8, whenever we print x, now we know x equal to 6, right, from this line. So we're going to print out 6. I hope that makes sense. Do you see what we did? The variable created by a function is unique to that function. Okay? It doesn't exist to the global variable. It's created and destroyed. So we just cover it back up. Whenever you see something like this where they're all the same, just know that every single time, even if they have the same name, even if these are all still x, this x and this x are different. Okay? So if I were you, I would just rename that. Okay? Because then it makes it a little less confusing. Sound good? I hope that made sense. Okay? Next one. Let's go into conditional statements. Yay! Okay. So we have, I guess, 3 types. We have an if condition, just straight up. So if the condition is true, we're going to execute this code block here. And then if it's false, we're not going to execute that at all. Okay? And then we're just going to continue execution here. So you have 2 situations. If it's true, you're going to do 1, 2, 3, right? So this is if it's true. And if it's false, you're just going to run line 1 and line 3, because this code block's not going to get executed. Okay? So this counts as one statement here. Now we have an if, an else if, and an else. Now the else if is optional. The else is also optional. We can just have the if, but only one of these, this entire thing, is considered one statement. So only one conditional statement will get executed, either the if, the else if, or the else. Okay, we'll see more examples of this. But, so we start off with the if condition. This code block will get executed if the if condition is true. Otherwise, we're going to keep looking. So we're going to go down. Okay? Just like here, if this wasn't true, we go down here. If this condition isn't true, we go down to else if. Okay? If this condition is true, so if our else if condition is true, and the previous one was false, so that's insinuated by the fact that this code block was not run, okay? Then we're going to execute this code block, okay? And if this one wasn't true, then we would jump down to else, and then we would execute this code block if all the above conditions were false, okay? Now the important thing here is the else statement, right? Because we know that if we got to the else statement, then this one wasn't true. None of these ones were true. Now the else if and the else are optional. We can just have the if condition. This executes if it's true. If it's false, it goes here. So this is kind of the same as an else, right? Oh, you don't have brackets in Python. Okay? So only one of these will get executed, and then it'll continue here like normal. Okay, let's do some examples. Here we have a function called compareInt. So we're going to give it an integer, and for each of these statements, for each run, we have a bunch of if statements, okay? Each one of these is a separate if statement, okay? So we can run all of these. So we're going to start up here. Let's set, in our main, let's set x equal to 5, right? So this is going to run second, then we're going to come here again, and then we're going to start running our code. If this condition is true, we're going to print out this, okay? And then we're going to continue execution. That's the big thing, okay? So we're going to run If this condition is true, we're going to run this, and we continue execution. If this one's true, we're going to run this, and then we're going to continue execution. Okay, there's a little bit of nuance there, but let's show you what happens. Okay, the important thing here is it's not an if else or if else if else. Okay, so all of these are going to be checked. It's not like if this one is true, then we're done. Okay, we're going to check all of them. Remember, if the condition is true, we execute, otherwise we go to the next block. Versus, if this condition is true, then we're done. We just continue executing here. Okay? So we have x equals to 5 right now. Let's look at our console. Is x less than or equal to 10? So is 5 less than or equal to 10? Yes. So we're going to print less than or equal to 10. Okay? Oh, exclamation mark. Cute? Cute. Okay, so we ran this one because this condition was true, so we ran this. Then we're going to continue execution. Is x equal to 5 less than or equal to 20? Yes. So we're going to run this one. Okay. And in our console, we're going to get less than or equal to 20. Okay. Then we're going to continue execution. Is x less than or equal to 30? Yes, so we're going to go here. And what's this? It's a return statement. Remember, in our functions, if we come across a return statement, we terminate immediately, okay? So here we're just going to return that. We're not going to print it out. If we were to choose, like, if we were to say print, oh, I forgot to call the function. Okay, if we were to print this out, then we could say less than or equal to 30, but still we didn't do that. Nothing's getting printed out here. We can save that somewhere, do whatever we want with it, right? But it'll stop here. This will not run if this condition was true, okay? Because as soon as we see a return statement, we stop. Don't mind the fact I messed up all the numbers. If this was not true, like let's say we had 35, right? So if this was not true, we would go here, and then that would be true, and then we can print this out, okay? But if we go here, we return and we end it there, okay? That's why our type contract here, it's a little hint, right? You're either going to get a none, so we're just going to print, or you're going to get the string from here, x less than or equal to 30, that condition being true, and you returning something, in this case, a string, okay? Let's continue. Now we have an if else. So let's have x equal to 5 to start, right? And we'll remember to call that. Okay, so we start off, we define the function, we run this, we run that, and then we'll come back here and we'll start running in the code block. Okay, so let's look at our console. Okay, is x less than or equal to 10? Yes, perfect. Okay, so because this condition was true, that's the only one we're gonna run. We don't run the else if, we don't run the else. In this case, we have no else if, but we're not gonna run the else. So this doesn't get run, and we would continue here. Or in this case, we would go back to main. Okay? Now let's set x to something different. Let's set x equal to 15. Okay? We would go here as normal, but now this condition isn't satisfied. So if that condition isn't satisfied, in all other conditions, we just run this one. So we're going to go to our else. Okay, now we have another if else. We can have nested if else statements. Cool. So is x less than or equal to 20? Yes, in this case. Okay, so we're going to run this. And because this condition was true, we're not going to run the else. Okay, so it would run this and then would run down here or whatever was there. So in this case, we'd go back to the main. But here we'll print greater than 10, but less than or equal to 20. Cool? Cool. Now, what if we had something bigger than 20? Set x equal to 25. So same thing's going to happen. We're going to compare. This one's going to be false. This one's going to be, we're going to go to the else statement, and then we're going to go here. This one's going to be false. So in all other conditions, we're going to run the else statement, right? And we're just going to print greater than 20. Okay. So I hope that makes it a little bit more clear. So if we have an if with a condition, right? If it's true, we go in here. Otherwise, we continue down here. If we have an if condition and an else condition, we run one or the other, but not both. Okay? And then we would continue execution down there. Sound good? Let's do another example. So now we have a new compare integer, okay? And we have else if statements here. Notice we have multiple. That's allowed. That's okay, okay? But all of this is one statement. So only one of these is going to get run. Cool? Cool. Let's say x is, we'll do 25. Cool. Let's do compare int x. Okay. 1, 2, 3. We're going to go back here for 4. Okay. We're going to go to the if statement now. Is 25 less than or equal to 10? No. So we're not going to run this one at all. We're going to go check the next statement, okay? Is 25 less than or equal to 20? No. So we're not going to run this. We're going to go to the next statement. Is 25 less than or equal to 30? Yes. So we're going to print this out, and we're not going to run the rest because we only run one of these statements, okay? If there was anything after this, then we would run it here after this, okay? So this would go 8, and anything here would go 9. In this case, we would go back to our main. Sound good? Sounds good. So in this case, we print greater than 20 but less than or equal to 30. Now let's do loops. Fun! So for a variable in a sequence, we just repeat this block of code. Okay? While we're still in this sequence, we're going to repeat the block of code. Now, what's a sequence? It can be a string, a list. We're going to talk about that soon. Tuples, etc. Not integers. Do not try to loop through an integer, okay? You can turn an integer into a string and then loop through that, but the integer itself is not a sequence, okay? And then once that's done, just like the if statement, we're going to go right here and continue execution, okay? And let's say the sequence was like empty and you couldn't actually run this block of code. That's okay. You can just go straight here, okay? So we're going to remember from string splicing, right? We have a start, an end, and a step for a range function. So it produces a sequence of integers, okay? Starting at 0 and up to and excluding the end value. It's the exact same thing, okay? So for I in range 11, notice that we have the little end equals a space, so we're going to print 1, we're going to print a space. We're going to print 1, we're going to print a space, okay? So for I in range 11, remember that we start counting at 0, okay? So first times around, I equal to 0, okay? We're going to enter here, we're just going to print out that I, cool? 0 and a space, because our end is a space, okay? Now I equal to 1. We're going to print that out, 1, and it's going to keep going, so 2, 2, 3, 3, and it's going to keep on going, Now, do we print out 11? No, because this is our end condition. We do not print out the end. Okay, that's our end. Up to, but not including our end. So it's going to be 0 to 11. Notice this is a range of 11 numbers though. So that's what's happening there. Okay? So now let's see one with the start step, or start and end step. Okay? So let's start at I equal to, oh, we're not starting at 0, we're starting at 1. Cool. Starting at 1. Okay? So we're going to print out 1. Easy as that. Now we're going to take a step of 2. So we're going to go to I equals to 3. We're going to take a step of 2. We'll print out 3. Take a step of 2, print out 5. Take a step of 2, print out 7. Take a step of 2, we're going to print out 9. And then we can't get to 11. Okay? Because we're going up to but not including 11. So that's our sequence of integers. So it's important to note that a variable created by the for loop can't be changed while it's running. Okay, so if I had like for I in, let's write this out, for I in range 10, right? If I were to do I equals I plus 2, this is not working. It's still just gonna go 0, 1, 2, 3, so on, so forth. Okay, it's not going to update the I. It can't be changed. But instead we can use an accumulator variable. So this is very important if you need to count anything. Okay, this is usually, you might see this question if you're asked to like fill in the blank as a multiple choice. They give you options. Just keep in mind that you can't change this variable. Whatever variable is in the for loop, you can't change it while it's running. Okay, so we have I count vowels. Cute? Cool. Let's do a string. Let's do Mississippi again. Okay. And then we're going to count vowels. We're going to feed it our string. Okay, so we're going to go back up here and we're going to start running. So we have count equal to 0. So that's the number of vowels we have. Okay, and we're going to run for character in phrase. So, whoops. For character in string. If the characters in this string, so a string of vowels, we're going to up the count. Okay, so let's see what it's doing. So first time around, first time around, we're looking at our M. Okay, is this character in this list of vowels? Obviously no. And so this condition isn't satisfied, so we're not going to run it. Okay, we're just going to loop back up with the next character. Cool? So we're going to run this again, and we're going to run this again. Okay, now is this character in that list of vowels? Yes, so we're going to go into here, and we're going to increment our count. So now our count is 1. Okay, cool. Now we're going to go back up to the loop. 11. We're going to look at S. That one's not in the character, the list of vowels, obviously. So we're going to go back up. We're going to go to 13. Now we're going to go for the next character, and so on and so forth. Okay? I'm going to stop writing the indices just so I'm also out of room. If I'm going to stop writing the indices, we're going to check, is that character in that list? No, so we're going to go back up to the loop. Now it's an I. Is that character in that list? Yes, so we're going to run this. We're going to set count to 2 now. Okay, then go back to the loop, back through the loop to the next one. That's not in it, so we're not going to run this. Back through the loop, we're going to check if this is in the list of vowels. That's not. So we're not going to run the count statement, so it's not going to change. When we get to I, the character is in this string of vowels, so we are going to increment the count. So now count is 3. Okay? Now we're going to go to the next character in our string, which is P. That's not going to satisfy this, so this isn't going to run. Then we go to the next one. Not going to satisfy, not going to satisfy. And then lastly, we end off with our I, our last run. So this is in the string of vowels, so we're going to set count equal count plus 1. So now count is 4. Okay, and we're going to return 4. So that is what is happening. That was what I was insinuating whenever we did the target, this s.count target. Okay, that's basically what it's doing. Cool? Cool. Now we have while loops. So this is good if you don't know exactly when you want to end your loop, but it's a little tricky because you can have an infinite loop. Okay, so the important thing here is this block of code is repeated until this condition is false. As soon as that condition is false, we're going to this line. Cool? Cool. Okay. So here we have the exact same thing, just as a while loop. So we have a count, we have an I, and then while my index, this is my index of the string, is less than the length of the string. Notice that's not less than or equal to, because what happens, let's say this is 1, 2, 3, 4, 5, 6, 7, 8. That is 8 characters long, right? So the length of S is 8, right? If this was less than or equal to 8, what happens when I equals to 8? With caffeine as my string, this is 0, 1, 2, 3, 4, 5, 6, 7. What happens when I try to index 8? It'll crash. Okay, so it's very important. We can either do I is less than or equal to len s minus 1, or just do less than. Okay, make sure that it's not exiting the possible indices. Okay. So we're doing the exact same thing. If the character at the index of my string is in the list of vowels, we increment. Okay? And then we're just going to print it out. Now the important thing here is this is our condition, right? And every single time we run this loop, we're updating this condition. So eventually we are going to exit this loop. Okay, because at one point, let's say when I equals to 8, right? When we run this loop 7 times, I is going to be equal to 8. This condition's not going to be satisfied anymore, and we're going to be able to exit. Okay, if I didn't have this line, right, I is going to be 0 forever, and it's just going to keep on running, and you're not going to get anywhere. Okay, cool. This is 0, 1, 2, 3, 4, 5, 6, 7. Those are our indices, okay? So first time around, we have I equal to 0. Is my string at 0 in the list of vowels? Yes, so S0, what is that? C, right? That's my first, the character index 0. Is that in my list of vowels? No. So this is not going to run. We're just going to go here. Okay, to I equals I plus 1. So now I equals 1. Cool. Let's run it again. We go back here to check that the condition hasn't been left, by the way. So let's go back here. Is S1. That's A. Is that in my list of vowels? Yes. So we're going to go into my count, and we're going to increment it. So now count, I'll make it a separate one. Count is 1 now. Cool. Okay, then we're going to always once that's done, we're going to come back and continue execution. We're going to do I equals I plus 1. That's 2. Okay. We're going to check, is I equal to 2 still less than 8, which was the length of our string? Yes. So let's go back here. Is S2? What's that? That is an F. Is that in this list of vowels, or the string of vowels? No, so we're not going to run this. We're going to go right here. I equals to 3 now. And do you see how it's looping through, right? So it's, long story short, it's going to check F. It's going to check F. None of those work. E is going to work, so count's going to become 2. I is going to work, so count's going to become 3. N is not going to work, and then E is going to work again. So it's going to be 4, and we're going to print out 4 at the end. The important thing here is that this condition here, eventually, since we're updating I, we're going to be able to leave the loop. Okay, that's the key thing. If you have an if statement, right, and you were updating in here, if this if condition never, if this condition was never true and you never ran this, then you'd be stuck in this loop forever. Okay, so it's very important that you know for sure that you are going to be leaving this loop eventually. Sounds good? Cool. Next up, we're doing lists. Second last topic, I believe. This is a mutable sequence of objects. Okay, so it can be a combination of numbers, strings, etc. It's closed by the little square parentheses and separated by commas. The little elements are separated by commas. Okay, big thing here is that it's mutable. We can actually change it. Okay, it shares a lot of same properties with strings, aside from the fact that it's mutable. So we can check the length. That's the number of elements in the list. We're just doing LST because list is actually like the type, so we don't want you to get confused. So LST is our list, okay? Indexing and slicing work the exact same way. So let's say we have our list here. Oh, look how cute! CSSA loves ITI 1120 because we do. Notice it's a combination of numbers and strings. That's okay. Okay. The length of it is how many elements we have. We have 1, 2, 3, 4. Perfect. The length is 4. Okay. Now, remember, we start indexing at 0. So 0, 1, 2, 3. Okay, so what's this here? That's index 1, so here. And then we can index that further. So this index at 0. So that's the first character there, right? So we have our little less than or equal to sign. Okay, sounds good? Sounds good. So we can double index that, okay? We can also do the start and step. In this case, we're reversing it. Notice that the actual element itself didn't get reversed. Okay, that would be another double index like this. But that's not the case here, so we're all good. We just reverse this, so now 1120 ITI loves CSSA. Cool, cool. Important part here is that this is a little bit more confusing because you can change strings, but this is a brand new string, or sorry, this is a brand new list, okay? So our original list is still this one, okay? The big thing here is that we can change that element, okay? So remember, we can index, this was a heart before, now it just goes the other way, so we can change that. So now at index 1, we have this, okay? Notice that this is the list itself. It's changed the actual list, okay? It's not a brand new list. It's changed the list, okay? However, you can also do that. You can also give it a brand new list. So these ones have the same values, but they're not the same list. This is a new list right here. This is a brand new list. Whereas this one is a changed version of our original list, okay? The one that was like this, okay? That's all we changed. This one, everything is technically new. Cool, cool. We can also concatenate lists the same way that we concatenate strings. We smush them together. So we have our list 1, Rachel loves, okay? List 2, CSSA loves ITI 1120. We combine that together, what do we get? We get a big list. We're gonna have Rachel loves CSSA, which loves ITI 1120. How cute. Very true too. Okay? Now let's go into methods. So this is the big thing. Because we can modify that string, it's going to modify it if applicable. Okay? So this one's not going to modify it. It's just return a count. It's going to count the number of times this element is in our list. Okay? So here's our list. It's our office number twice with a 0 in between. Okay? It's going to count the number of times we have an element 0. So that's 1, 2, 3. Perfect. So this one's not going to modify anything because it's just returning the count. Okay? But sorted list returns a sorted list. So this one does not modify it. But if we did list.sort, that's going to sort, aka modify the list. Okay? So let's set sorted list equal to the sorted function with list. Okay? So this is going to be 0, 0, 0, 4, 4, 6, 6, 7, 7. Okay? Which is going to be put into the sorted list variable. Okay? But as of now, this list is still the same. We didn't modify it yet. Okay? Now we're going to go to this line. And remember, we do the right-hand side first. So list.sort, we're going to change this. So instead of doing that, we're going to sort this out. This is the same list, just sorted, okay? We're changing the list. We're modifying the list. It's not a brand new list, okay? 0, 0, 0, 4, 4, 6, 6, 7, 7. Now we're just going to check if those are equal. Yeah, they have the same elements in the same order and everything, so this is true. Okay? Just one sorted doesn't modify the list, and .sort does. Okay? More methods. Append. We're going to put the element that we're given, we're just going to stick it on to the end of the list. Okay? So we had, remember our list got sorted, so it's still under the same variable, but now it is sorted. So 0, 0, 0, 4, 4, 6, 6, 7, 7. That's our list right now. If we're going to append our smiley face, we're just going to add that to the end. So notice we have a bigger list now by one element. We just added it in there. Okay? So now we modified our list. So we're going to add my little smiley face in there. How happy is she? Okay? Now we have pop. It removes and returns the element at position I. So if we don't have an I here, it's just going to remove the last by default. Okay? So let's make a variable called popped_lm, and we're going to do the right-hand side first. So we're going to pop out, since there's nothing there, we're going to pop out the last element. Okay? We're going to take this out, my little smiley face. We're going to take that away. Okay? Okay. So that's the popped element, and we're going to set that into the variable popped element. Okay? And then we print that out. We print out my smiley face, and my list is back to normal. Okay? I don't have my smiley face in there anymore. Sound good? Cool. Now let's do some examples. So what is printed and returned if we call modify list with this list, this input list? Okay? So we'll start here. We're going to start here. We're going to run modify list, and then we're going to go, this is all docstring. Oh, this is docstring, so we're going to start here. Okay, now we have a new result list. Cool. I'm going to write these down so that we can see very easily what's happening. Right now, it's just an empty list. Okay, now we have a shortened list. That's input list from start to 5. Okay, not including the index 5. Okay, so this is 0, 1, 2, 3, 4, 5, 6. So we're going to go 0, 2, 4, not including 5. That's going to become our shortened list. Okay. So for each element in our shortened list, so 0 3, 2, 5, 6. If that mod 2 is equal to 0. What mod 2 is equal to 0? That means you can divide it by 0 and you have a remainder of 0. So this is even numbers. We're going to print that out and we're going to add that to my result list. Okay? So let's go through that. Okay? We're going to start at 0. Remember, this is the extent of my shortened list. Start at 0. Okay, is 0 mod 0, 0? Yes. So we're going to go into the condition. We're going to print that out. So we have 0. Cool. And we're going to append that. So now we're going to add 0 to my result list. Okay, let's go back up and we'll go to the next one. So now we're going to 3. Okay. Is 3 mod 2 equal to 0? No, it's an odd number, so it's equal to 1. So we're going to ignore this. We're going to go back into our loop. We're going to go to the next element. Is 2 mod 2 0? Yes. So we're going to print that out. And we're going to append it. Okay. Next element, we're going to go to 5. Is that mod 2 equal to 0? No, we're going to skip this. We're going to go back up here. So we're at 6 now. Is 6 mod 2 equal to 0? Yes, it's an even number. We're going to print that out and append it. Beautiful. And now this loop is complete because we're done our shortened list. We've been through all elements, okay? So we're going to return that. So this right here is what gets returned. So this we can capture somewhere. Question: does this get printed? No, because as soon as we encounter a return statement, we are done. Function's over, okay? So this one will not get executed because we've already returned. If we put this before, then we would have 0, 2, 6 added on to our console. Okay, but since that didn't happen, this is our final print. Cool? Cool. So now we're on to one of, if not the most important part of this midterm. Okay, we're going to do memory and aliases. I feel like this was not covered too extensively in class, but I remember it being like a significant portion of our midterm. So please pay attention to this part. If you can't study anything at all, study this, okay? Not saying that you shouldn't study, but you know what I mean. I'm going to be explaining the theory. We're going to do so many examples, okay? Please bear with me here. I know it can be confusing, okay? We're going to use an analogy. We're going to think of computer memory as an infinite set of shelves, okay? So each shelf has a number, its address, and it can hold an object, so it's content, okay? Now when we come across a variable equal to expression, so let's say this is z equals 1 plus 3, okay? Cool? We're going to store the object/value of the expression as the content of a shelf, and then the variable is going to get the address of that shelf, okay? So here we have z equals to, the value here is 4, okay, because it's 1 plus 3. That's going to be the content of a shelf. Let's say this is in shelf 1. Okay, so in shelf 1, I have my value 4. Okay, so now instead of reading all of that, I'm just going to give it the shelf number. Okay, does that make a little sense? So instead of seeing z equals to 4, I look at z, I go, oh, it's in shelf 4. Or sorry, it's in shelf 1. So I'm going to go to shelf 1, and then I'm going to read the content. So I'm like, oh, okay, it's 4. So z equals 4, okay? We'll see so many examples, don't worry. By assigning a variable to another variable, we're giving it the same shelf. We're not giving it the same object. We're giving it the same shelf number, okay? And by pointing to the same shelf, they're pointing to the same object, okay? So we have Z equal to, this was shelf 1, right? Okay. And we know that that was 4. Okay, so let's fill in our shelf. We have shelf 1 has content 4. Okay, now I have an alias variable. So let's set that to Y. Okay, I'm going to set that equal to Z. And well, what is it? It's shelf 1. So instead of giving it the object, we're just going to give it the same shelf. Okay, so now these guys are both pointing to the same shelf. And so by consequence, they have the same content. So this is also going to have the value of 4. Cool. They're pointing to the same memory address. Okay, they're both pointing to 4. Good. Let's continue. So because they're pointing at the same shelf, if the content of that shelf changes, so it has to be a mutable object here, okay? So the only mutable object that we know right now is a list. If that object changes, variable and alias variable will both reflect that because they're pointing at the same shelf right now, okay? But if they're given a new object, they have a new shelf and they're no longer pointing at the same shelf. Okay, this is always going to happen with immutable objects. So think your integers, your strings, anything like that. As soon as you assign that, they're no longer alias variables of each other. Now let's use the previous example. We'll do some more as well. I have Z and I have Y pointing at the same shelf right now. Both pointing at shelf 1 with content 4, right? Cool. Now, 4 is an integer. So it's immutable, okay? So if we had said all of a sudden equal to 5, right? We can't change this number, okay? So this, again, brand new object, okay? So it's getting a new shelf, okay? So Z's no longer pointing here because we're giving it a new shelf. We're going to put Z here. We're going to give it shelf 2, and we're going to put 5 there. Do you see the problem here now? So Y is pointing to 1. Y is pointing to shelf 1, which is 4. So Y is 4 right now. And Z is pointing to 2, shelf 2, which has 5. Okay, so these two are no longer the same because we're pointing at different shelves. Okay, you're going to see so many examples. Let's go through it. What does the following print? Okay, let's put everything in shelves. We have A, right, equal to 100. I'm going to give that shelf 1. Cool. A is pointing to shelf 1. Cool. We have B also equal to 100. I'm going to give that shelf 2. Okay. Remember, these integers always going to be new values because they're immutable. Okay, we're not changing anything here. We're giving it new integers, even if they're the same value. They're not. They're different. Okay, different shelves, guys. Now we have C pointing to A. So remember, we're giving this the same shelf as A. So shelf A is pointing to shelf 1. So now this is pointing to shelf 1 too. So we also have C pointing to shelf 1. Okay. If we print C out, we're going to get the content of shelf 1 because it's pointing to shelf 1. And we're going to just read that. So we're going to print out 100. Okay. Now we're going to set A equal to 50. Remember, brand new object, brand new shelf. Okay. So now A is not pointing here anymore. We're going to give it a new spot. Let's put it over here. New shelf, and we'll put our 50 in here. Okay, notice C, A, no longer pointing to the same shelf, different content. Okay, so let's print out C again. Well, it's going to be 100 because it's not changed. Okay, sounds good? I hope you're still with me. We'll do so many more examples. Let's go. Okay, we have A equals 100. I'm going to put A here. We'll give it shelf number 1, and it has 100 in it. Okay, we have B equal to 50. I'm going to put it here. We're going to give it shelf 2, and content we'll set to 50. Okay, let's print A and B, which is just going to be 100, which is A, 50. So when we read it, we're going to read A is shelf 1, which has 100. B is shelf 2, which has 50. Okay? Now let's introduce a temporary variable. We have temp equal to A. So we're going to assign them the same shelf. So this is shelf 1 right now, right? Now we have A equal to B. So A is going to have shelf 2. So we're going to just move that over, right? Now they're both pointing at 2. Okay. Now B is set to temp. Okay, now temp is pointing to shelf 1, right? So now B, no longer pointing there. A is still pointing at 2. B is going to point at shelf 1 with temp. Okay, now let's print A, B. So A is pointing to shelf 2, which has content 50. And B is pointing at shelf 1, which has content 100. So look at that. We successfully swapped it. Good? Good. Now let's see the same thing, but not the same thing. Now it's in a function. So we have immutable swap. Seems like it's doing the exact same thing. If we look at the code, seems like it's doing the exact same thing, but it's not. Remember, we're going to execute this first. We're going to ignore all this. Okay, then we're going to come down here. We're going to see A equals 100. Sounds good. Let's set A to this shelf. We'll get shelf 1, put 100 in it. We have B equal to 50. Give B this shelf and put 50 in it. Okay, now we're going to run our function, immutable swap A, B. So before that, what's happening here? Because this is X, Y, this is A, B. Basically what's happening here is we're setting X equal to A and Y equal to B. Okay? So we have X pointing at the same shelf as A. Y pointing at the same shelf as B. Okay? Now let's go into the function. We're going to set temp equal to whatever X is pointing at. So now this is shelf 1. Okay. We're going to set X to whatever Y is pointing at. So let's get rid of X here. We're going to point at the same thing that Y is pointing at. So now X is shelf 2. And then lastly, we're going to set Y equal to temp. So we're going to remove Y from here. We're going to point it at whatever temp is pointing at, which is shelf 1, right? So we did swap X and Y in a sense. So because Y is pointing at A, X is pointing at the same shelf as B. Okay? Sounds good? Now what happens when we close this function out? Print, number 9. Number 9, We're going to come back out. We're going to print A, B. Well, where are A and B pointing? A is pointing to 1, which is 100. B is pointing at 2, which is 50. So notice here, we did almost the same exact thing, except since we were working with X and Y this entire time, we did swap X and Y, but our A and B were unaffected. Make sense? I hope so. Because we did not change which shelves A and B were pointing at. We were changing which shelves X and Y were pointing at. Cool? Cool. Next example. So now we have a mutable swap. All right. We're going to run this. We're going to say, oh, yep, there's a function called mutable swap. We don't care about the rest for now. Cool. We go back down here. We have a list with 150 in it. Sounds good. Let's give a list pointing to shelf 1 with 150 in it. Okay. It's just the wrong color. Beautiful. Now, we're going to run a mutable swap with our list. Great. Now we're in here. 4, 5. Okay. So I'm going to set temp to the list index 0. We have a new variable temp. We're going to store that. Okay. And we're going to store the first element, so index 0 of list. So list, pointing to 1, pointing to this, the first element is 100. Okay, let's put that in there for temp. Then this here, we're not creating anything new, we're modifying, okay? So whatever was in list, going to the shelf, this is our list, right? Whatever's in index 0, we're going to put index 1 there, okay? So we're going to get 50-50. Notice, we just modified the list. I didn't make a new shelf, same content. We're modifying it, okay? That's step 6. Next step, okay? Temp is going to go into index 1 of our list. So, temp points to 2, which is 100, and we're going to set that to the first, or the element at index 1. So that's this 50 here is going to get replaced by the value of temp, which is 100. Okay? Now, if we print out our list, notice we're still pointing to the same shelf. So all those changes applied, even though we don't have a return statement, right? We weren't collecting anything. It's just because of the fact that we're not giving it a new shelf. We're modifying what's in the shelf, okay? So lists are mutable, so we can change this stuff, right? And it'll stay at the same shelf. So when we print the list out for step 8, we're going to get 50, 100. Right? Because we're going to go to list is here, we're going to go to shelf, and we're going to print out that. Cool? Cool. Careful, because this one is different. Okay. We're going to define new mutable. We're going to set a list to a shelf to 150 as the value. Sounds good? Now we're going to run our new mutable function. You can probably guess by the name. They're not going to name it like that for you, but you can probably guess by the name what's happening here. Uh-oh. What's this? It's a new list. As soon as you are giving this, there's a big difference between modifying a list, so like doing this, and assigning a brand new list. Okay, because this is changing it, this is a new list. Okay, if you don't have an index here and you just have that variable, that's a new list. Okay, I know it seems kind of silly, but that's what's happening here. Okay, so we're going to evaluate the right hand first. We're going to take the list, which is here, here, here. We're going to take the element at index 1, which is 50. Then we're going to do list here, element at index 0, which is 100. Remember, this list is not the same as this list, because this one is strictly for the function. So let's rename this. We're going to set this to flist for function list, okay? This will be function list. So now we have function list pointing to a new shelf with a new content. Okay, notice this one didn't change because we gave it a brand new object, so this is pointing to a new shelf. Okay, so when we come back down here for step 6, we print out list. List is still pointing here, still shelf 1, still 150. So we get 150. So those are the 3 main cases you're gonna have. They're either gonna be immutable, in which case it's never gonna change. It's always gonna be a new object. You're gonna have a mutable where it does change, or a mutable where it is a new object. So it's not a change. It's a brand new object. Okay. Let's do an example. Putting that all together. We have a mystery function. This is more like what you're going to see in the exam. They're not going to be nice and tell you what it's doing. So we're going to define that. Okay, we don't care about it for now. We don't care what's in it for now. We're just going to continue on with our operation. Okay, so I have a list 1. We're going to point it at a shelf, and we're going to give it content 111. Cool. Then I have list 2. New shelf with content 000. Okay, now let's run mystery. Our mystery function, how spooky. So 5, we're gonna go up here, we're gonna go in our function. First things first, let's rename things. Flist. Cool. So what's this doing? It's setting right here, it's setting flist 1 equal to list 1 and flist 2 equal to list 2. Because remember, the variables in this function are exclusive to this function, okay? Even though list 2 and list 2 are named the same, they're not the same. So we're just going to rename it to make it less confusing, okay? So we have flist pointing the same thing as flist 1 and flist 2 pointing the same thing as list 2. Cool. So these are f's. Great. Now for step 6, we're going to change, remember, we're going to change the element at index 0 of flist 1 to 999. Okay, so flist 1 is pointing to a shelf, it's pointing to this. We're going to change the element at index 1, which is 1, to 999. Okay, so that's changed it. Okay, now in comparison, flist 2, that's a brand new list, remember? So flist 2 is not pointing here anymore. She's going here. We have a brand new shelf with 1, 2, 3 in it. Okay, now you can probably see what's happening again. We're going to close out this function. We're going to go back down here, and we're going to print list 1. Well, list 1 is still pointing to the right shelf, so list 1 is pointing to 1, which has this content, and it's going to print the changed value. So 999 1, 1. Then we're going to print out. Now we're going to print out list 2. Remember, list 2 is still pointing at shelf 2 because this operation changed F list 2 to a new shelf, okay, because we gave it a new object. List 2 is still unaffected, and that's the one we're talking about right now. So list 2 is pointing at shelf 2 with 0, 0, 0 still in it. It's pointing at 0, 0, 0. Okay. I hope that helped a bit. It definitely is very confusing, especially with the functions. I highly recommend renaming it like that. The only reason I don't have them named differently is because they will totally do this to you on the exam. And I want you to be exposed to it so you know what to do. Even if it makes it a little harder for me to explain, I want you to know what's happening, okay? I hope that makes sense. Again, if you have any questions at all, feel free to message us in the Discord. It's in the description box below, as well as you can also find it on our Instagram page. We have a designated ITI 1120 channel, and we have a tutor role, so you can @tutor with your question. We'll get back to you as soon as possible. If you want to review this before your final as well, feel free to come over during my office hours. The updated hours will always be on our Instagram page. But other than that, I hope this helped. Good luck on your midterm. It's one of my favorite subjects, but this midterm is quite tricky, especially with stuff like this. Remember, if you need to review anything else, review functions and memory, please, please, it'll do you a favor, okay? Reach out to us if you need help. Other than that, thanks for joining me today. Have a great night.